Alright, welcome back everybody. It's still Mr. Szabo, and what we're going to look at now is determining whether a point lies on the line of an equation. And there's two ways that we can do this. The first is just using algebra. So remember that we have the ordered pair 3, 4. Well, anytime we have an ordered pair, we always have our input independent variable or x listed first, our output, our dependent variable or y listed second. So in this case, we're saying, hey, x is equal to 3 and y is equal to 4. Is that true in this equation? Well, that's like checking our function rules. If I input 3 into this function, does y equal 4? So if I take 3 and input it in for x, I take this 3, input it in here, I get 12 minus 8, I get 4, and yeah, guess what? 4 is equal to 4. That makes me happy. So does this point lie on the line? Yes, it does. Because any coordinate that satisfies the equation like this means that point is on the line. That's what a line does. It represents all coordinates that do work in that function rule. The other way is to graph it and check. Okay. So if I were to do that here, we would recognize that our slope is a 4, which means I can look at that slope in two ways. It's positive 4 over positive 1, or negative 4 over negative 1, with a y-intercept at 0, negative 8. There's a pattern there. We were negative 8 happy here. Negative 6, negative 7, negative 8. That's where we start. When I apply my slope, 1, 2, 3, 4 up, 1 to the right, positive 4, positive 1, positive 4, positive 1, positive 4, positive 1, 1, 2, 3, 4, and positive 1. Here is my line. It looks like this. Now I'm just going to check. Does this point 3, 4 lie on that line? 1, 2, 3, 1, 2, 3, 4. It sure as heck does. It's right here. So, yes, it does. All of these points, all of these ordered pairs, in fact, would work in this function rule. Now, it's not always as cut and dry. Sometimes it's easier but more confusing at the same time. Take a look at this example as a way of addressing that. X equals 9. We haven't looked at that yet. That's a funky looking equation because we don't have a y at all, and everything else we had y's. But remember, we had two different special types of slope. One was 0, and we saw that. That was when we had stuff like y equals 5 or y equals negative 8. But if I have x equals 9, I should be able to know algebraically pretty quick. What's x equal in this ordered pair? Well, in this ordered pair, I'm saying that x is equal to negative 2, and that y is equal to 9. I'm checking to see if x equals 9. No, it doesn't. X is equal to 2, or negative 2. That's not equal to 9. So this should not be on my actual graph. Now, let's take a look. If I plotted the point, negative 2, positive 9, that's going to be way up here. That's the ordered pair, negative 2, 9. Is that on my graph? Well, how do I graph x equals 9? I kind of step back in time here. When y was equal to 5, it meant every single ordered pair had 5 in for my y coordinate. That's a horizontal line. Well, guess what? When it's x equals, in this case, I have not actually given the function or given the equation, but we're stepping back a day. I want to write my equation. Y equals mx plus b, and I'm not even going to put the plus in there because it might be a minus. But I've given you everything you need. I told you you have a slope of 1/2, so m equals 1/2. We have y equals 1/2 x. The nice thing is, when I tell you it passes through this point, remember these were the ones that made us happy. Well, that's not real happy. That's more happy. Because my x is 0. That means this is my y-intercept. My y-intercept is at a positive 7. I can make this 1/2 x plus 7. Now, the good news is, even if that wasn't a y-intercept, I didn't need the equation necessarily because I can apply my slope from any point. We'll have more about that later on. But I start at 0, 7 here, and I'm going to apply my slope of 1/2. Up 1, right 2, up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, and down 1, left 2. Here's my graph. Now I can check this way. Does this point lie on that line? -1, -2, 1, 2, 3, 4, 5, 6. It sure does. So I should be able to check this algebraically now. When my x is -2 and my y is 6, does y equal 1/2 times -2 plus 7? I'll use purple again. Okay. And again, order of operations, 1/2 times -2 is -1. -1 plus 7 is 6. And yes, 6 equals 6, so we are happy. So back to what I had mentioned earlier. I need this equation if I'm going to check algebraically, but if I'm just going to graph, I don't. If I hadn't given you 0, 7, but said, hey, does it go through or graph the line with a slope of 1/2 that passes through the ordered pair, let's say 4, 9. I could have started by plotting 4, 9 and then applying my slope of up 1, right 2, down 1, left 2, down 1, left 2, down 1, left 2. So it doesn't matter which point I have. As long as I have a point and a slope, I can graph my line. Okay, there is one more video for this lesson, and it's going to be relatively quick, I think, because it's a lot of word problems, but you guys are fantastic at these at this point, and so it's going to be a lot of review. Go ahead and watch our third and final video of the day.